Good morning, everybody. I am Dr.Suchilipsa, Associate Professor in Chemistry. Today I am going to discuss the chemistry short questions with answers. What is de Broglie's relation? Lambda is equal to h by p, or lambda is equal to h by mv. P is equal to mv. P is the momentum, where lambda is the wavelength of the particle, p is the momentum of the particle, h is the Planck's constant, m is the mass of the particle, v is the velocity. Question number 2. What is the physical significance of psi square? Psi square leads to the probability of finding a particle with a definite value of energy within a certain domain in space. In case of an electron, psi square at any point around the nucleus gives a measure of electronic charge density at that point. Question number 3. Write Schrodinger's three-dimensional time-independent wave equation. The wave equation is given as follows: del square psi by del x square plus del square psi by del y square plus del square psi by del z square plus 8 pi square m divided by s square into E minus V psi is equal to 0, where x, y and z are the space coordinates of the electron along x, y and z direction respectively. M is the mass of the electron, E is the total energy of the electron, H is the Planck's constant, V is the potential energy of the electron, psi is the amplitude of the wave called wave function, and del square psi by del x square is the second derivative of psi with respect to x, and so on. Question number 4. If the wavelength of the electron is 1 nanometer, what is the velocity of the electron? We know mass of the electron equal to 9.1 into 10 to the power minus 31 kg. So de Broglie's relation is written here: lambda is equal to h by mv. From this equation, we can write the expression for v. V is equal to h by m lambda. So v is equal to h by m lambda. So v is equal to h value is 6.626 into 10 to the power minus 34 joule second, which is the Planck's constant, divided by m into lambda. M is the mass of the electron into lambda. Lambda is the wavelength of the electron, which is given in the question, 1 nanometer. So that is equal to 10 to the power minus 9 meter. So h by m lambda we put here in this equation. So v, finally we get v as 7.28 into 10 to the power 5 meter per second. Question number 5. Calculate the energy of a photon for light of wavelength 400 nanometer. So here we have to calculate the energy of a photon. So as we know that the energy of the one quantum or photon E is equal to h nu, and in place of nu we can write c by lambda. So now the equation becomes E is equal to h into c by lambda, and h value we know, that is the Planck's constant, into velocity of light is 3 into 10 to the power 8 meter per second divided by lambda. Lambda given in the question 400 nanometer. So 400 into 1 nanometer is equal to 10 to the power minus 9 meter. So 400 nanometer is equal to 400 into 10 to the power minus 9 meter. So E is equal to 4.96 into 10 to the power minus 19 joule. So the energy of the photon is 4.96 into 10 to the power minus 19 joule. Question number 6. The speed of a projectile of mass 1 gram is known within 1 micrometer per second. Calculate the minimum uncertainty in position. So we know that according to Heisenberg's uncertainty principle, delta x into delta v is equal to h by 4 pi m. So delta v is written here, and delta x formula is h by 4 pi m into delta v. So here delta x we can calculate by putting the value of h, Planck's constant, 6.626 into 10 to the power minus 34 joule second, 4 into pi, then mass of this projectile given in the question 1 gram. So mass we will write 10 to the power minus 3 kg, and this velocity, uncertainty in velocity, is given 1 micrometer per second. That means that is 10 to the power minus 6 meter per second. So now we'll get the uncertainty in position is equal to 0.527 into 10 to the power minus 25 meter. Question number 7. Define phase and component. So a phase may be defined as an homogeneous, physically distinct and mechanically separable portion of the system which is separated from other such part of the system by definite boundary surface. Component. A component is defined as the smallest number of chemically independent constituents of a system by means of which composition of each phase can be expressed directly or in the form of chemical equation. Question number 8. Calculate the degree of freedom of decomposition of calcium carbonate. So here calcium carbonate decomposes into calcium oxide and carbon dioxide. Calcium carbonate is in the solid state. Calcium oxide is also in the solid state and carbon dioxide is in the gaseous state. So here two solid phases and two solid phases will form two different phase. Two solid phases are here and one gas phase is here. So total number of phases will be 3. So P stands for phase, number of phase. So P is equal to 3. 3 phases are here, 2 solid phases and 1 gas phase. So P is equal to 3. And here in this case component will be equal to 2. C stands for component. So C is equal to 2 because the compound 3 compounds are present here and the composition of each compound can be expressed with the help of at least 2 constituents. So that's why the component will be 2. C is equal to 2. According to the phase rule, F is equal to C minus P plus 2. So F is equal to C is 2 here, P is 3 here. So 2 minus 3 plus 2 is equal to 3. So the degree of freedom is 3. So the system is trivariant here. Question number 9. Calculate the degree of freedom of the equilibrium which exists between the solid iodine in the solid phase and iodine in the vapor phase. So here, so two phases are here. One is solid iodine, another one is vapor iodine. So two phases are here. So P is equal to 2 and the substance is 1, that is component is 1. So according to the phase rule, F is equal to C minus P plus 2. So F is equal to component is 1 here, that is iodine. So 1 here minus 2, two phases are here. One is solid phase, another one is vapor phase. So phase is 2 plus 2 is equal to 1. So degree of freedom is equal to 1. So here the degree of freedom is 1. So the system is monovariant. Question number 10. Triple point of one component system is invariant. Explain. So one component system, we can take the example of water system or sulfur system. So in one component system means here C is equal to 1 and at the triple point all the three phases solid, liquid and vapor coexist in equilibrium. So three phases solid, liquid and vapor, so phase is equal to 3 and since it is a one component system, so C is equal to 1. So F is equal to C minus P plus 2. So 1 minus 3 plus 2 is equal to 0. Since the degree of freedom is 0, so the system is invariant in the triple point. Question number 11. Write down the condensed phase rule. Why is it named so? So condensed phase rule is expressed as F is equal to C minus P plus 1, where F is the degree of freedom, C is the number of component, P is the number of phases. And here 1 is the variable factor. 1 is the variable factor which represents temperature here in the condensed phase rule. So that express the temperature. In this system, the effect of pressure is negligible. So we write 1 here instead of 2. So since we write here 1 instead of 2, so the degree of freedom also reduces by 1. So the phase rule is called condensed phase rule. Question number 12. What is the eutectic composition and eutectic point of bismuth cadmium system? The eutectic composition of bismuth cadmium system is bismuth is 60% and cadmium is 40%. And eutectic point is 140 degrees Celsius. What do we mean by isomorphous system? The binary system in which two solids are completely miscible with each other. The two solids constitute the isomorphous system must have same crystal structure, similar radii, similar electronegativity and similar valency. Question number 14. Write down two limitations of Lambert-Beer's law. Lambert-Beer's law is not satisfied if the radiation is not monochromatic. The law is applicable in case of dilute solutions. Question number 15. What do you mean by auxochrome? Auxochrome can be defined as any group whose presence brings about a shift of the absorption band towards the longer wavelength. So example is, that is OH, NH2, NHR, COH, carboxyl group, CN and Cl, etc. Question number 16. What is the effect of conjugation on chromophore? Due to conjugation, the pi electrons are delocalized and the pi star energy level is lowered. Pi star energy level is the molecular energy level. So that energy level is lowered. So the energy required for transition is decreased. And since energy required for transition is decreased, so wavelength is increased. Since energy is inversely proportional to the wavelength. Here we can see in this compound, there is a difference between the energy of the pi star molecular orbital and pi molecular orbital. But when conjugation occurs, the energy of this pi star molecular orbital is decreasing here. So the energy gap, pi star minus pi, energy gap E2 is now lesser than E1. So since energy of transition is decreasing, so now the compound will absorb at the increased wavelength. What is the difference between bathochromic and hypsochromic shift? Bathochromic shift, the absorption maxima is shifted towards longer wavelength. Example, benzene absorbs at 255 nanometer, which is colorless, but aniline absorbs at 280 nanometer. So here the wavelength is increasing, that is a bathochromic shift, or also it is called the blue shift, and that occurs due to conjugation. Due to conjugation, wavelength increases. In hypsochromic shift, the absorption maxima is shifted towards the shorter wavelength. Example is aniline absorbs at 280 nanometer, whereas it absorbs the UV radiation at 203 nanometer in acidic solution. So now the wavelength of absorption now decreases for the same compound when it is kept in the acidic solution, and that is the decrease in the absorption maxima, or decrease in the wavelength of absorption of the radiation is called hypsochromic shift. Question number 18. What is the selection rule for rotational transition? The selection rule for rotational transition is delta J is equal to plus minus 1. Delta J can be plus 1 or delta J can be minus 1, where J is the rotational quantum number and whose values may be 0 or 1, 2, 3, 4 like this. In absorption of energy, delta J is equal to plus 1. That means the molecule can transit from the molecular energy level, rotational energy level, J is equal to 1 to J is equal to 2. That means delta J is equal to 2 minus 1. So delta J is equal to plus 1. That means energy is absorbed. So similarly, when energy is emitted, so here the delta J will be minus 1. What is the selection rule for vibrational transition? The selection rule for vibrational spectroscopy or transition is delta V is equal to plus minus 1, where V is called the vibrational quantum number. V can be 0, 1, 2, 3. For absorption of energy, delta V is equal to plus 1, and for emission of energy, delta V is equal to minus 1. So these are the vibrational energy level of the molecule. So these molecules can transit from the V is equal to 1 to V is equal to 2 when by absorbing energy, or it can transit from V is equal to 2 to V is equal to 1 by emission of energy. So delta V can be plus 1 in case of absorption of energy, and delta V can be minus 1 in case of emission of energy. Which of the following diatomic molecules shows pure rotational spectra? So out of this HF and CO show pure rotational spectra, because a molecule will show rotational spectra if they have the dipole and their dipole moment changes. So since HF, so they have the dipole, and CO, they have the dipole, positive dipole and negative dipole, positive pole and negative pole. So they have the dipole, and so they have the dipole moment. So here only HF and CO can show the rotational spectra, whereas H2 and N2 cannot show rotational spectra. Which type of molecules show vibrational spectroscopy? Heteronuclear molecules whose dipole moment changes, such as HF, HCl and CO, can show the vibrational spectroscopy. So thank you all.